Hello, welcome back to the Keeping It Cool broadcast. We'll be looking at liquid cooling today. So this is our Cooling AI at Scale panel, looking at are CDUs the bottleneck or the breakthrough? Today's panel, we will be partnering with CoolIT, and we'll be looking at the vital role of CDUs in enabling high-density, scalable liquid cooling. So in this episode, we'll be looking at practical insights, lessons learned, real-world deployment, and unpack a little bit more about those emerging CDU designs and what we're seeing in terms of demand for next-generation infrastructure. Now, I'm very excited to introduce our three speakers here today. We're joined by the CoolIT team here today to talk a bit more around the CDUs. I'm joined by Neil Mulji, VP of Product, Kamal Mustafi, Vice President of Engineering, and Paul Lee, Director of Professional Services. Hi, guys. How are you doing today?
Great, Hi, I'm doing well.
Very good.
Thank you for joining. Now, to kick us off, I'd like to each ask of you if you could share a little bit more around your role, your experience, and some of your current priorities at CoolIT. Neil, if we start with you on this.
Absolutely, and just reiterating, it's a pleasure to be here and talk about this topic, which we are all excited about. So Neil Mulji, I'm the Vice President of Product. My team and my group is primarily focused on product strategy, all around all things liquid cooling in the industry. And we also oversee our product development at CoolIT. So we work across the industry with various internal and external partners. I've been with the organization for 6 years now and just really focused on where we're heading in the industry as liquid cooling continues to scale.
Perfect. Thanks, Neil. And Kamal?
Yeah, thank you very much. This is Kamal Mustafavi. I'm the Vice President of Engineering at CoolIT. I have been here at CoolIT for over a decade right now. The main responsibility of me is to oversee the engineering activities across all line of products. So mainly responsible for the design and development of all the products we are developing on the data center side and also on the consumer side, anywhere from the cold plates to the manifold to the CDUs, all land within my group. I'm happy to be here today.
Great, thanks, Kamal. And finally, Paul?
Paul Lee, I'm the Director of the Professional Services Group here at CoolIT. So my team is responsible for the field deployment of our products. So that's kind of the final design, deployment, and the integration and then long-term support with our end users and clients.
Great, thanks, Paul. I really appreciate you all coming on just to share some of your insights. So we'll start off with looking a little bit more about those key factors in CDU selection. Neil, I'm going to come to you for our kickoff question. What are some of the critical factors in CDU selection today?
Yeah, so I'd look at two key things. There's obviously the performance side of things. When we look at selecting a CDU, you want to understand what sort of heat loads you're managing, what flow rates are required, pressure in the system, looking at the size of the system, so how many racks or servers that you might want to be cooling. And then the other thing on the performance side is in terms of what are you looking to cool or manage today versus, do you want to future-proof it and kind of select something that might work for you down the road as, again, these requirements continue to creep up. The second side is planning and operations. What reliability and redundancy is needed. Now, typically in compute systems, most groups are looking for a very high level of uptime. It's quite critical. You may consider things like, how do I get my product to site? And that may affect some of your selection. Paul might talk a little bit more about this, but the serviceability and maintenance of those systems as you're operating. And then also looking at what is my current facility infrastructure? Do I have access to things like facility water, we call it the primary side? Is it chilled or is there warm water access? And when you look at those two things, you may select two key categories of CDUs. So you have your liquid to air systems. So if you don't have facility water available in your data center, you would look for a system that can still do heat capture at the server level, but ejects it into the air of the data center, where it's taken care of by the air handling systems. Those are more efficient than only air systems, but not quite as efficient as your complete liquid-to-liquid system. So if you do have facility water available, you can do a liquid-to-liquid CDU that will take that heat and then eject it out into the facility water, and that typically is much more efficient in the operating side. And then the last thing I'd say is the deployment model, the size of the deployment will also impact you. So three form factors you can get CDUs in: a rack-based CDU, typically relevant for, let's say, enterprise customers, where maybe it's a single rack or maybe just a handful of racks. The Coolant Distribution Unit sits inside the rack alongside the servers. It can be rolled right onto the site, much simpler to deploy. As you start to get the larger systems, 5, 10 plus racks, then you might look at a row-based CDU that sits in the aisle, takes up footprint, but can serve a larger quantity of racks in your data center. And then finally, we see with large cloud service providers, typically they're looking for a, we call a facility or skidded CDU form factor. So that will actually sit outside your data hall, sit in the gray space, something like a mechanical room, and it's fully tied into the infrastructure piece. I think those would be the highlights or the key elements, and I think my colleagues would be able to shed a bit more light on some of those details.
Thanks, Neil. Really good overview there. A lot of detail. As you said, your colleagues might share a different insight. Paul, I'm going to come to you. Can you talk us through some of those end-to-end approaches for CDU selection?
Sure. So Neil really highlighted kind of a lot of the key factors, but one of the first things we'll do is we'll look at that total heat load that we do need to deal with, and then also what the flow rate is required for the specific application and what's in the racks. And then the next thing we'll look at is we'll look at a lot of the facility constraints. And so Neil mentioned, do we have facility water? Are we working with an air system, as well as power and space constraints? And so once we have those kind of defined, we can look at whether we use the liquid to liquid or liquid to air CDU. And then once that's kind of decided, we can also go into the location, as Neil mentioned as well. So whether you want to put that CDU in the IT rack itself, have it near the IT racks in the white space in an in-row CDU, or if you want to go to a CDU in the mechanical space. And I think the big thing with that is understanding the different trade-offs. And so having to do with scalability, the extents of the technology cooling system, which is the cooling loops, the piping to take the cooling fluid from, or the coolant from the CDU to the racks themselves, and then as well as performance, footprint, and ease of maintenance. So they all have different trade-offs. So at the end of the day, part of that end-to-end is highlighting those performance requirements, as well as making sure that the selection fits your requirements for scalability and maintenance.
Yeah, thank you, Paul. So I want to dig in a bit to something you said. So around scalability, I mean, as we know, the buzzword now is AI, and we're seeing that in every conversation. I'm interested in digging into how you think CDUs might evolve in response to that AI demand and that increasing demand that we're seeing. Neil, maybe if you take this one.
Yeah, sure. So because we're involved in the entire solution, so we do produce the solutions for the server level cooling all the way out to the coolant distribution unit. Really where it all starts is at the processor level. So the AI processors that we're seeing coming out today are over a kilowatt of thermal design power versus what we used to see, maybe even a few years back, 250 to 500 watts at a chip level. And so that is where the demand is really being driven. So racks are now going up to 100, 130 kilowatts today for AI racks. And over the next 4 to 5 years, we see the potential for a megawatt worth of thermal design power and cooling that we have to manage in a single rack. So it's quite dense. And when we start to look at performance, typically the industry is looking at this point about 1.2 liters per minute flow rate per kilowatt of cooling, and up to about 1.5. So when you think about it, Kamal would be able to expand into this, is just the amount of pumping that's required, the heat exchanger that you want to select and be able to manage that heat load. Those are the ones that are really driving what is actually needed, and how do you support the trends that we're seeing, not just for today, again, because it's that rapid scaling of these requirements and managing that. And for us at CoolIT, we're driving our product strategy in that direction. We're looking at systems and CDUs that are over 2 megawatts worth of cooling, and that's just for the row-based CDUs. We're looking at even larger form factors beyond this, multi-megawatts worth of cooling.
Yeah, and for our audience members that may be less familiar with CDUs or are now turning to liquid cooling, can you in brief just really reiterate kind of what makes a CDU truly scalable?
Sure, yeah. So there's a few elements. There is the ability to obviously manage that specific heat load. What does that limit look like for that particular product? And then looking at the pumping performance, those, purely from a thermal management, Kamal, maybe you jump in. I'd say those are really the critical factors: your flow rate, your pressure, your heat exchange. Those are really what make them scalable. If they're sized and designed appropriately, they will serve you well into the future for products that we might be using.
Yeah, Kamal, can you share maybe your engineering insights onto that?
Absolutely. So when it comes to the CDUs and the scalability, so definitely the CDU is really a portion of the whole ecosystem when it comes to liquid cooling. They are practically the interface between the facility side and also what we call a secondary side or technical cooling side for the data centers. So when it comes to CDUs and scalability, definitely everything comes back to the cold plates when they get mounted to the processors inside the servers. So definitely the CDUs are serving these cold plates just to make sure they function properly. And of course, like we want the cold plates to function properly, so the health of the servers are out there for their life. So in order to do so, so these cold plates, so there are many technologies around the cold plates these days, but eventually the right amount of a flow rate has to go into these cold plates at the right temperature and at the right pressure. So as part of the overall ecosystem to design this end-to-end solution, we look at the manifold, we look at the CDUs, we look at all the connection points and the cold plates all together, and we do a simulation analysis just to make sure all these components, they can work together properly, and are the CDUs at the right size, can they produce the right amount of flow and the pressure for these cold plates, and that is really critical for the functionality of these cold plates. So as you're seeing more and more of the processors coming to the market with higher power, they are hungry to have more flow rates. So it is essential that the CDUs are being selected, they have enough headroom when it comes to the pressure and the flow, so that they can feed multiple different generations when it comes to scalability of a liquid cooling in a certain data center when it comes to architecture selection. So we work carefully with our customers when it comes to designing the whole architecture and how the whole ecosystem should work together. And of course, like there are many factors come in place, such as redundancy, modularity, and the reliability of these systems. So these days, modular data centers or creating these pods of liquid cooling is something that is really trending these days. And that is something that can help from modularity perspective for scalability of the CDUs, and make sure that the CDUs are sized properly to work and function with the cold plates, depending on what is coming on the facility side.
Great, thank you, Kamal. And I think if we move the conversation on to talk a little bit more around some of those operational considerations for people looking at this. For CoolIT and what you're working on, what would you say some of the factors are to consider when deploying these liquid cooling devices, specifically within existing centers already? Paul, do you have any thoughts on that?
Yeah, I think the integration is a real critical phase for that. Typically, in an existing data center, a lot of these data centers are not really designed with liquid cooling in mind, and they're often fairly densely packed as is. So, one of the first things we'll look at is space. So, space constraints. If we're putting a technical cooling system loop in, so that, as we mentioned before, that the coolant loop between the CDU and the IT racks. Where is that going to go? So is there space? A lot of times in existing data centers, it'll be a fairly tightly packed space under the floor. And so we'll look at that and work with the operator to route those lines to make sure that it performs as expected. And then another thing we really look at is tying the CDU into the building management system. And so making sure that the CDU is integrated as a part of the overall infrastructure and is not a add-on or tacked on separately to the rest of the system. And then the real thing we look at as well at the end is a thorough commissioning process. So once we have the CDU in place and we have all the infrastructure in place, really dialing in the performance and reliability and serviceability of that unit to make sure it's balanced for the IT racks that it's servicing. And then I think just the overall theme is we really want to look at it at a system level to make sure that we're not just plugging in the CDU kind of at the end of your row or into the rack, but that it's being integrated into your facility.
So that holistic perspective to when
That's
we're integrating the CDUs. Yeah, and so when you're doing that, when you're looking at something holistically, how are we ensuring operational reliability, especially in high density environments like we're seeing? And how are you ensuring thermal efficiency?
I think that commissioning process again is quite important. We'll tune the CDU to make sure that it's reacting properly. So as the heat load ramps up and down, the CDU performance is, or not the performance, the CDU is reacting to that appropriately. It's tied in properly to the building management system so that the end user can adjust as required and understands what's going on. And then making sure that CDU selection has been made with that serviceability and redundancy built in. So one example would be an in-rack CDU is quite dense, and it's part of the IT rack. So that's a really good feature. But because it's so tightly space constrained, oftentimes serviceability is a little bit of a trade-off in that case. And then something else we really look at and we want to see is redundancy. So all of our in-row CDUs will have redundant pumps, sensors, and filters. So any service you need to do, or whether that's kind of regular preventative maintenance or even a larger pump swap, you can do that without actually affecting any of the IT equipment. So the pumps, the sensors, the filters, they can all be isolated. And so you can swap those out or clean them without, again, as I said, shutting down the CDU or impacting the overall performance of the system. And so, again, that's kind of part of that holistic overview and making sure that you understand the selections you're making so that long-term service and the redundancy is built in so that the system can continue to keep the IT racks up.
Yeah, thank you, Paul. And so again, looking at that long-term, that holistic, I'm wondering kind of what should operators be expecting beyond that hardware? So, when you're buying a CDU, you're going beyond hardware. What should operators really be looking at? Neil, do you have any thoughts on that?
Yeah, absolutely. It's very easy to say it's just simply a component as part of a data center. We take a very different approach, even to what Paul was speaking about, is when we set the requirements for our products, we really take a system level view of what is needed. So the CDUs are not simply just some modular component inside a larger system. We really think of it as operating as a single system, starting at the chip level, all the way out to your infrastructure. And you really need to consider that when you're selecting a piece of hardware. How does it work for me in my data center, as if you consider it one large system all working together in tandem? You want to make sure you're future-proofing your selections. What we see again is, again, starting at the silicon side, that the pace at which those thermal design powers are increasing are just going to keep ramping up what you need from a cooling perspective. And so making sure, if I'm going to plan to upgrade my servers over time with the latest and greatest, is this product going to serve me today? Is it going to serve me in a year? Is it going to serve me in 5 years? Or is it going to become completely unusable or not keeping up with the pace of that development? So that is a key, I would say, consideration. As Paul's touched on, how do you deploy and maintain these systems? How does it impact you as an operator in the data center? Do I need a rack CDU, row CDU, or facility CDU? That might depend on the type of data center owner or operator that you are, whether you're an enterprise, whether you're a large institution, or a large cloud service provider. And I think one of the other things I'd point to is, how do you tie into controls? That's also quite important. So we focus on offering a wide range of communication protocols, because the CDU is really the brains of the entire system. Most of the components that go through it are completely passive, and all the controls sit inside your CDU. So how am I going to tie that into my building management system? And can I adequately control and monitor it with what I use today? I think those would be, it's not just simply a piece of equipment you buy, install it, and just turn on. And we wish it was as simple as that. There's a bit more to it. And our team certainly help a lot of our customers and partners in how to go about it effectively.
Yeah, you heard it here first, guys. There's a bit more to it than just simply turning it on. Kamal, I'm sure you can input here on some of those extra things that we need. Why should a data center care about the type of liquid cooling used and the cold plates deployed in the server?
Absolutely. So when it comes to selection of liquid cooling types, so there are many things to consider when it comes to having data centers to adopt liquid cooling. The overall data center infrastructure is a key term there. The thermal efficiency, the reliability, and on top of everything, there is the upfront cost for adopting liquid cooling for any technology, plus the long-term operating costs. So these are the top factors to be considered when data centers they go and adopt liquid cooling for future deployments. So there are many aspects of things to consider when it comes to selecting a liquid cooling type. So we have a single phase liquid cooling, we have a two phase, we have immersion, and there are many other technologies out there that are available for liquid cooling. However, as the mainstream for adopting liquid cooling these days, single phase direct liquid cooling is something that is vastly being adopted in data centers, and this is exactly what we're doing at CoolIT. So for when it comes to liquid cooling, these factors should be considered, so that for the period of 3, 5, or 7 years that these liquid cooling systems they are going to work in data centers, we need to upfront consider all these costs that are going to go around them, the reliability aspect of them, and just to make sure that the adoption of liquid cooling is there for that data center for scalability. If there are going to be more servers or more racks to be added, is that system good enough to take care of those for future technology coming down the road? So as I mentioned, single phase has proven a technology that for a good long period of time, it can take care of the high heat load, is a reliable solution, and it's something that is a more mature technology compared to other technologies there. And we are seeing overall the whole industry is moving that direction. Majority of the standards out there are related and being connected to single phase liquid cooling. And we are definitely thinking that single phase is going to be the mainstream for the future when it comes to liquid cooling.
Do you think that the industry is ready to adopt liquid cooling at the pace needed? I mean, you mentioned there that the 3, 5, 7 years in the future. Do you think that's true, would you say?
I personally, I believe that the overall adoption of that is really not happening with the same pace that the whole technology is really evolving on the IT side. So hence the reason that we believe that the data centers, they are really not ready to adopt liquid cooling in a perfect land. So what is really happening is that we are seeing that current data centers, they're really having a hard time to retrofit liquid cooling because the infrastructures, they were meant to do mainly air cooling. And really retrofitting liquid cooling into that space is going to be very costly. So hence the reason that we are seeing a lot of data centers, they're looking for more of an interim solution just to adopt liquid cooling because of the rise of an AI and high performance computing that are really out there, and everyone is trying to bring it to their data centers and enable those. And we know that for those systems to work, liquid cooling is a key factor. So we know we are at the limit that the overall power for the racks is easily exceeding 30 to 40 kilowatt. And that's very challenging these days for air cooling to handle that. So this rapid change of the power in the racks is really mandating the data centers and the operators to think about liquid cooling. And right now we are seeing a lot of new data centers that are being built. Definitely they're thinking about the infrastructure that it is really meant for liquid cooling applications. But a lot of the current ones or the legacy data centers are really having a hard time to adopt that. And a lot of things to be considered when it comes to adoption of liquid cooling. This is not just the hardware is going to be purchased, it's going to be put in data centers, and everything is going to function. So there are a lot of from chip all the way to the air outside. Everything has to be connected and has to function very well. It has to work very well together, just to make sure that the IT side on the rack side they are functioning as expected.
Thank you. And so if I can just talk to more again about that scalability angle, what does a real world scalability look like from one rack to a full row or even entire facility? Neil, if you want to come in on this.
Yeah, in terms of, we talked about this all operates as a system. So you could actually have some fairly large racks all interconnected together. So one of the elements could be the control side. What we do on our requirements is we can actually tie together multiple coolant distribution units all operating as a single system that's connected to a multitude of racks all working in tandem together. And so with that, Paul would be able to speak more to how do you go and deploy something like that, because you've got variations in pressure and flow and managing all of that. But from a controls perspective, all those CDUs, which are the brains of the system, effectively are working together, and so they have to be aware of what each other is doing and what they're seeing for pressure, flow, temperatures, and talk to each other and make sure that system, again, the reliability being one of the most critical factors in terms of uptime, but also thermal performance. And so we do implement various communication protocols and enable those to work all together. So you can continue to scale out your builds. We do see with some customers, they'll start with a smaller deployment, and then over time they start to expand that deployment to increase its size as they bring more servers into the facility.
Thank you. So interesting. And Paul, what does deployment look like?
Excuse me.
Especially, what do the install and maintenance realities look like for scalability?
Yeah, Neil really hit it on the head there, I think, with the understanding kind of that group control and then just having a grasp of the longer term plan so you can understand that going in. So some of the big things to be aware of, if you are starting with that smaller unit, but you do understand you're going to be expanding it in future, it's setting yourself up for success from the start. So making sure that technology cooling system, that loop is sized appropriately so that in future you can expand. Something that's simple and is often overlooked is having shut-off valves and blanking on that technology cooling system. if you have to come in later and you have to drain the whole loop to add a new CDU and a new IT rack, that's downtime. Whereas if it's kind of set up from the get-go for expansion, then you could start adding racks and CDUs without taking down your existing equipment. And then as well, understanding and working, we can work closely with the facility operators as you add new racks and new CDUs, working to understand when to kind of split those out into maybe a new pod or tie them into the existing, and then kind of go through that tuning process again to make sure that each rack is getting the appropriate flow, and the CDUs are working together in that group control mode. So we can come back in and do some more balancing to make sure that that scaling, as you're adding on, it's balancing across the entire system.
Yeah, thank you. And Kamal, I'll come to you again for your perspective. I think it's quite interesting. What do you think scalability will look like in a real world application sense?
So I would say when it comes to scalability of liquid cooling, to me what really matters, and I think it becomes like it's a trend for the future, is really the modularity aspect of it, and I would say like generally a standardization around liquid cooling is really key for scalability. So when it comes to deploying liquid cooling, it is really essential that you have the whole architecture being designed in a way that all these racks are being connected through the manifolds and the cold plates and the CDUs all together. So they are being architectured and in a proper way that they are ready for either a next gen comes in there that kind of use the same level of architecture, or it is being designed in a way that's following certain standards that any change in those in any coming years doesn't interrupt the whole infrastructure. And that is the key, because infrastructure for data centers is very costly. So it is really important to have this future vision in mind before deploying liquid cooling. And we wanted to make sure that scalability not only happens within the walls of a data center, but also outside when it comes to facility side. And that is really essential for scalability. So you don't want to build data centers for 1 or 2 years. And thinking ahead, that would be great.
Perfect, thank you. Some really interesting answers there around scalability. And I think let's come through onto best practice and that deployment cycle. Paul, from your perspective, what is the role of professional services in helping operators implement those liquid cooling systems?
We typically come in right at the end of the sales cycle, I would say, and so we really help with that final design and final CDU selection. And I think, especially because it's a relatively new technology for a lot of operators, our team has a lot of experience in the deployment. So it's just highlighting best practices and things they may not have thought of. And so setting yourself up for future expansion, making sure you understand the trade-offs in terms of serviceability and space constraints, and just really working with the operators on education so that they understand how they can integrate this into the data center and have it be successful for their current deployment. And then, as we mentioned, with a lot of the scalability and as well as the higher and higher power requirements that we're going to be seeing going forward based on some of the roadmaps we have right now. So just really understanding those trade-offs and setting yourself up for success today and tomorrow.
Yeah, and Paul, if I can just stick with you, I've got another question just regarding your services. What are some of the biggest maintenance challenges that you're seeing at the moment? Can you share a bit more about your experience?
Yeah, I think right now a lot of it is around access and making sure you have appropriate access and redundancy. And then we touched on it a little bit with scalability, making sure that the systems are built to enable that expansion without shutting down existing racks. But redundancy, I would say, so when you do have to do maintenance, you want to make sure that your CDU and your system continue operating. So especially with a lot of this equipment is critical equipment with high uptime requirements. And so you want to be able to make sure you can do your basic preventative maintenance. So swapping and cleaning filters, checking the coolant levels, up to swapping sensors if they have issues, or even an entire pump. So you want to make sure your system is set up so that you can perform these maintenance issues without taking down any of the IT equipment. And then access, understanding if you have a row-based CDU, can you do all the maintenance with just front and back access, which with ours we can. So then if you have it in a row and you have racks next to it, then that's okay. You can still go in and do all that work. Whereas if you don't have that feature, you have to make sure that you have the space around it to do that, again, so that you don't have to take down IT equipment, take downtime to do your basic maintenance.
Thank you. Really interesting there, just on some of the work that you've been doing. Kamal, I know the other two have mentioned that systems level approach. It's quite a buzzword in this conversation. From your experience, what do you think a systems level approach can bring to that rapidly scaling liquid cooling environment?
Yeah, so it's an interesting and it's an important factor when it comes to liquid cooling, adoption of liquid cooling. So for system level, while any of the components in liquid cooling, they may function by themselves properly, but eventually they all have to work together in an ecosystem. And I just wanted to make sure we understand that really whole liquid cooling doesn't end at the CDU level. Still, there's a lot of work that at the facility level has to happen, that needs to bring in the right amount of the water or the coolant to these CDUs, so that this heat transfer function can really work. So thinking about the whole ecosystem scalability of liquid cooling, everything really starts from the cold plates on the chip, on a processor, in a server, and goes all the way outside of a data center, going to a dry cooler or a cooling tower or a chiller. So all of these, they have to function together very well. We talked about it, that they have to be sized properly so they can feed multiple generation of racks coming to the data centers. And this is all part of the adoption of liquid cooling. And if that system level is really not happening, really what it does is that you may have a portion, even a small portion of this infrastructure not working, it will interrupt the whole liquid cooling ecosystem. So really a proper selection of these components are key. One key example I mentioned here is just material by itself. So the within material list in liquid cooling is something that we are seeing, although there are many standards out there, but we are seeing that not necessarily everyone is fully educated, that how critical it is just to make sure that the within material list in the whole ecosystem of liquid cooling is being selected properly, is being deployed properly, and there's enough cleaning, enough flushing in the whole systems all together, because just to make sure the health of a coolant is there, because coolant is the blood of the whole system. So one example really is that material compatibility, that I think it's being underscored overall when it comes to liquid cooling, and not properly accounting for all the components around it. It's going to be really damaging the whole functionality of liquid cooling systems in a data center for sure.
Thank you. Appreciate you all sharing your comments. I'm just looking at the time, so we've got a few minutes left of this conversation. I want to throw to you the question that's brought us here to discuss this. Are CDUs the bottleneck or the breakthrough for AI at scale? I'm going to ask each of you this question. Neil, you're at the top of my screen if you want to kick us off.
Sure. I'll say it depends, right? I think, this space is getting incredibly competitive. The demand for liquid cooling is going up significantly. And I think it comes down to selecting the right products and partners in this ecosystem. We keep hammering on this point, but taking that system level approach, and that's why it really matters, is you can be ready to scale with CDUs. They can really support where AI processing and computing is going, but you want to make sure you have the right products and systems to enable that for you. And so, that some of the challenges in the industry we see are there is really no standardization across for liquid cooling. There are different bodies, that some which we're a part of, that are trying to achieve that. But even when you look at CDU performance, it gets incredibly difficult to compare product performance from one vendor to another. How do you go and evaluate those and make sure that what you're getting is actually going to support you the way we were talking about today? I think that will help. From our perspective, we take this system level approach in terms of how we set the requirements. So we're working with the silicon vendors directly at the chip level, understand what they need. We work with the end users. We work with the OEMs who are manufacturing the servers. We take a lot of inputs from our professional service team as well and say, hey, when you're putting these products out in the field, what are you running into? What are the problems we need to solve? And then we work with Kamal and our engineering groups in putting all those requirements into our products and say, how far can we push the envelope here? And so when we come out with requirements, we're focused on obviously very high performance because that's where the industry is going. So that's heat capture, flow, pressure requirements. We also look at density. That's another challenge that maybe we haven't touched on today is if you think about a coolant distribution unit, that takes up space inside your data center. And that's space that you could otherwise use for actual compute, right? And so we are focused on high performance, but in a very small, dense footprint so that you can put as much compute inside your data center. And then finally, that reliability, uptime, and serviceability, so you can actually operate it effectively over the lifetime of that system. So I think we're headed that way, but I don't think it's a very consistent delivery that you're seeing across the industry. We certainly like to think we're providing great value here, being over 20 years in the direct liquid cooling space and that history, that knowledge, and being a full solution provider that we think we're driving that forward.
Thanks, Neil. I mean, such an innovative space. Kamal, I'll throw this question to you again. Are CDUs the bottleneck or the breakthrough for AI at scale? What are your thoughts?
So definitely there are a lot of things to think through this, but I would say there are a lot of options for CDUs. I answer this question this way, like there are a lot of options for CDUs out there right now. We are having CDUs for many years working in liquid cooling at CoolIT, so definitely experience is there, maturity is there. What I think is between the two is more important personally is that breakthrough of AI, which has definitely surprised everyone in the whole industry, the whole ecosystem of liquid cooling, from anyone that is owning a data center all the way to the one that is supplier or the vendor of a component to liquid cooling. So there's a lot of learning that has to go through just to make sure that this whole chain on the supply chain side is really working together properly. And I think as much as that we have had this interruption of a new technology coming to the market, we haven't had a lot of deployments and a lot of adoption of liquid cooling in many data centers around the world happening. And that is really a lack of maturity in the whole industry right now. So we are not having like the two working at the same pace. And this is really interrupting. So the IT side and the cooling side, they have to work together properly and at the same pace because they are really dependent onto each other. And hence the reason that I think definitely these days and these months, so we are seeing that every processor vendor, they're introducing a brand new chip and a processor bringing to the market. Everyone wanted to adopt those, bring those, and we are seeing that it's going to be a quick change on the power, quick change on the whole racks, the interface to the whole facility side. But we are not seeing that necessarily the whole industry is ready for. So there's a lot of work we are doing at the OCP level. There's a lot of work we are doing on ASHRAE side. We are putting together guidelines, standards out there to educate people to understand on that. But definitely, I see that scaling up an AI right now is really just really highly dependent on the cooling side and making sure that people are there to adopt it very quickly and up their knowledge in the liquid cooling.
And on that, Paul, I'll come to you for the deployment side of this equation. What are your thoughts on our final question?
Yeah, I think the CDU and the liquid cooling is what's enabling or allowing these high density clusters for AI. The big thing is that deployment strategy. and how are you setting yourself up for the scaling? So I think the current AI racks are already a pretty significant increase in power density and cooling requirements. And so when we are working with clients to deploy CDUs and a liquid cooling system overall, it's like, how are you setting yourself up for success? So balancing your needs of today, and then also understanding that with the rapid scale of innovation and the higher and higher density we expect to see going forward, how is that deployment lined up to allow you to do that, so that you're not going through this whole new cycle every year or two where you're having to come in and totally rework your system, but you're building it so that you can accommodate and expand kind of as your needs change and then as the technology scales with power and cooling requirements.
Perfect. Thanks, Paul. So 3 very interesting answers there to today's key question. Before we wrap up, I'd like to throw one final positive question to you all. We'd like to finish on something that's a bit forward-looking. I'm going to throw this out to you. In the next 18 to 24 months, what's one single advancement or a shift in liquid cooling that you're most excited about? And this is to
I'll jump in. So I know for me and a lot of others here at CoolIT, been doing this for well over 20 plus years as an organization, and I'm very excited to see the adoption of liquid cooling in general. It's up till a few years ago was not what we call anywhere close to mainstream, but where we see the processors going, and it is really, I think Paul touched on, enabling that to actually occur, right? This capability to cool these extremely impressive silicon that's solving some really major challenges in the world, and for us to be part of that and to make it really more mainstream, and the benefits of that, of enabling that compute, but also, when you talk about what it drives in terms of efficiency and operational costs, and bringing those down. So very excited to see that, and very excited to engage with the industry in general to educate them on how to do it, and how to do it really effectively, because while it is challenging, while it is complex, we know that it can be done really well and reliably with the right partners in place.
Fabulous. Thank you, Neil, for that final comment there. Unfortunately, that is all we have time for on this episode, but thank you very much to our speakers for joining and sharing your expertise, and thank you to CoolIT for partnering with us on this episode. To those of you watching, if you would like more information, or if you have any more questions, please do check out the resources below this episode. You'll see them on the screen. And also reach out to our speakers on LinkedIn if you find them and have any additional questions. This episode will be on demand shortly if you'd like to rewatch. But please do stay on and tune in at the top of the hour to the next episode in this liquid broadcast series. We'll be looking at addressing the liquid in liquid cooling. But that's it for now. Thank you and bye-bye.